Hey, welcome back to lesson 2 of trig functions and graphs. We're going to look at something new this time. We're going to look at something called a radian. Now, just like in degrees, radians are used to measure angles. And you're probably wondering, well, why do we need another way to measure something? In calculus, science, physics, you name it, measuring in radians is actually preferred because it can be a little more accurate, okay, and exact. So that's why you need to know how to do this. So let's take a look. We're going to skip the exploration part, cut to kind of what a radian is. And really what a radian is, it's the measure of an angle in radians. Okay, so 1 radian is basically when the arc length of a circle, really, equals the length of the radius, and it's the angle enclosed by that. So if I was to draw this on here, say we go like that, and this is like point B, then this angle here, if the radius is this and this is also equal to the radius, then this angle here would equal 1 radian. Okay, so that's really what a radian is. It's about 57 degrees, but we'll get into that in a little bit here. This actually leads us to a formula that's given on your formula sheet, and that's that the angle theta in radians is equal to the arc length A over the radius R. Okay, and we're going to take a look at oh, they drew that down here. Got ahead of myself there. Okay, so we're going to take a look at converting between degrees and radians on the next page. Okay, so we've got this drawn here. Now, we know one complete rotation from the last lesson in degrees is 360 degrees. And the arc length for one complete rotation, well, would be the circumference of a circle, which is 2 pi r, or pi times diameter, which is, I just gave that away already, the circumference of the circle. Okay, the ratio of arc length over the radius, if we're talking all the way around, the arc length all the way around would be 2 pi r over the radius, which is r. And look at that, if we simplify that, we would get 2 pi. So in other words, 360 degrees is equal to 2 pi radians. Okay, half the rotation in degrees is, well, half of 2 pi. Oh, sorry, we'll get there in a second. In degrees would be 180 degrees, half of 360, and the arc length for half a rotation would be half of 2 pi, which is pi. Okay, and then if we look at that arc length, pi over our radius, oh sorry, pi times r, arc length for half rotation would be pi r. Over r, again, we have pi. All right, so in other words, 180 degrees is equal to pi radians. Good. Okay, well that right there is our most important conversion, which they give down here as well. Pi radians is 180 degrees. So 1 radian would equal, actually this is where I'm going to divert a little bit, and we're just going to cut to this part, or the summary notes down here. Okay, converting between degrees and radians, since pi radians equals 180 degrees, if we're trying to convert from degrees to radians, we are going to multiply by pi radians, I'm just going to write that in, over 180 degrees, or if we're going from radians to degrees, 180 degrees, multiplied by 180 degrees over pi radians. All right, now angles. If you don't see a degree symbol after an angle, you assume it to be in radians. Okay, so, and I sometimes write the word rad just to reinforce that, but essentially I wouldn't have to. As long as there's no degrees, we know it's in radians. So just keep that in mind. All right, let's look at the next page and an example. Okay, example number 1 says, convert from degrees to radians. Give your answer as an exact value in terms of pi. Okay, exact value in this unit could be with a radical sign like what you're used to, like the square root of 3 is an exact value as opposed to rounding that to 1.73. Or it could be in terms of pi, which we know to be an irrational number, approximately equal to 3.14. So for this particular lesson, exact value means it's going to be in terms of pi. So 270 degrees. All right. We want to convert that to radians. We want to get rid of degrees. So those of you who've done science, unit analysis, where we can get rid of the degrees. So I want to have degrees on the bottom here so that when I'm multiplying by this ratio, the degrees will cancel. And then I know 180 degrees is equivalent to pi radians. So therefore, now we can multiply these. Now, if they said to the nearest tenth, like the next question, we could use the calculator. But exact value means we will have to keep pi as pi, which means don't be putting pi in the calculator at all, or you'll get a decimal you can't actually make exact anymore. So what we could do, either you could reduce this fraction, because you recognize that 90 divides into both of those, to get 3. So 90 goes into that 3 times, into 180 twice, and we would get, multiply across, 3 times 1 on top over 1 times 2 on the bottom. So our answer would be 3 pi over 2 radians. Or, those of you not a fan of fractions, what you can do is go 270 degrees divided by 180 on the calculator, and then go math fraction to change it back into a nice fraction. Okay, why don't you guys try 315, and we'll check back in a minute. So pause your video, please. Okay, so did everyone get 7 pi over 4? Okay, those of you doing it on your calculator, 315 divided by 180, and then math fraction, you get 7 over 4, and then throw the pi back in on your answer. Okay, next example, convert the following from degrees to radians to the nearest tenth. Okay, so nearest tenth doesn't have to be exact anymore. So when we write that we want to get rid of degrees, so 180 on the bottom, degrees cancel, pi on top, because we know pi radians equals 180 degrees, we would simply type that in the calculator as 70 times pi divided by 180, and then write down the answer to the nearest tenth. Okay, so let's try that and see what we get. Okay, did everyone get 1.2? Now, as long as I don't write a degree symbol after that, it's assumed to be radians. If you want to reinforce the fact that it's radians, we could write rad, just abbreviate the radian. Okay, you guys go ahead and try 205. Let's check back in a minute and see if we got the same answer. Pause your video, please. Okay, hopefully everyone got 3.6 rounded to nearest tenth. Okay, convert the following from radians to degrees. Okay, so now we want to go 2 degrees. So we would want to have degrees on top so that we end up with degrees. Now we know 180 degrees is equal to pi radians. So that's what we would be multiplying by, is 180 degrees over pi radians. Now, we could type the whole thing in the calculator and go pi times 180 divided by brackets 4 times pi. Okay, you need brackets around the 4 pi. However, we could reduce this first, make things a little easier. The pi's would divide to equal 1, and then 184 goes into 180. That would go in 90 times, and there we go. There's our answer. Okay, let's try it with negative 7 pi over 3. Now you're probably wondering what to do with that negative. Don't sweat the negative, just our answer will be negative, right? Negative just means that we rotated in a different direction. Okay, so you guys go ahead and get an answer for that, and we'll check back and see if you're right. Pause your video. Okay, we should have gotten negative 420 degrees. And of course, all these angles you could draw in standard position, something we learned in lesson 1. But we're not going to right now. Okay, example 4, convert the following from radians to degrees to the nearest tenth. Okay, so we're not going to get a pretty number like we did the last example. Okay, so we have 1.57 radians. All right, we want degrees, radians to degrees. So we want to have degrees on top, pi radians on the bottom. Okay, now the pi does not cancel with this word radians, okay? That's a mistake I've seen in the past students make. Okay, radians is just saying what the unit is. If you want, write rad here, and cancel that. But pi is a number, 3.14, okay? Don't be canceling that off with a unit measurement, okay? All right, so then grab your calculator. We're going 1.57 times 180, and then divided by pi on your calculator. And let's round to that to the nearest tenth when you get the answer. Okay, so go ahead and do that one and also try the next one and we'll see if we get the same answer. All right, pause your video, please. Okay, so on the first one, example 4a, you probably got a number like 89.95, and then it keeps going, but to the nearest tenth, that 5 would round the 9 up to a 0, and then the 89 up to a 90. So to the nearest tenth, oh, I made a little mistake there, I need to write 0.0, okay, to show that that is actually rounded to the nearest tenth. And then for part B, we have negative 1.4 radians. Again, don't worry about the negative. It just means the answer will be negative, as in a rotation angle that goes clockwise. And we're converting that into degrees, so 180 on top, pi on the bottom. Put it in your calculator. 1.4 times 180 divided by pi. And we should get, rounded to the nearest tenth, negative 80.2. All right. Now they kind of summarize things below with coterminal angles and reference angles, but really all you have to remember is that if you're trying to find a coterminal angle in radians, you're simply going to add or subtract 2 pi as opposed to 360. The method is the same as lesson 1. Principal angle is the smallest positive rotation angle, so instead of having to be between 0 and 360 now, it would be between 0 and 2 pi radians. Okay, and then once again, the reference angle is the acute angle formed between the terminal arm and the rotation angle of the rotation angle and the x-axis. So I'm not going to write all of those again. I kind of shunned this table from the first lesson. I think you should just draw it and reason it out, and that's the best way to deal with it. Those of you headed for calculus, you're going to want to work with these fractions. Those not, I'll show you a technique with the calculator on how to get the nice fractions. All right, now we're going to take a little bit of a detour here. Okay, we're going to finish up this part of lesson 2, and I would like you to watch the lesson on thinking in radians, because it's good to be able to kind of hear an angle in radians and kind of know where that is without having to do this conversion. Okay, so we're going to go off to that, and then we'll finish up the second part of lesson 2 in your workbook. So the next video you're going to watch is going to be using the worksheet, and it's called Thinking in Radians. All right, we'll see you there.